Okay, so as you're saying, the sum of the forces is still ma. So the force 6 minus t squared is equal to 5a. So if I divide the 5 across, I now get a relationship for a in terms of t. So then we just work through our integration process. In this case, I need a velocity, which is 1/5 of 6 minus t all squared. Use our integration rules, add 1 to the power, divide by the power, divide by -1 because of the negative t. So I get minus 1/15 at the front of 6 minus t all cubed plus some constant c. So I could pop that constant in there now. What was our initial condition? Initially at rest. So at t equal to 0, v is equal to 0. So if I pop that in, I'll get c is equal to 6 cubed on 15, which I guess just to tidy it up a fraction, if we think about 6 cubed as being 6 squared times 6, well then that 6 and 15 have a common factor. So it cancels down to a nice 72 on 5. So the rule for my velocity, if we take it across, given as 72 on 5 minus 1/15 of 6 minus t cubed. Find the speed of the body after 6 seconds. So if I put t equal to 6 in there, obviously my 6 minus 6 is 0, so I get left with 72 on 5. All right. And the distance travelled. So there's my speed at that point in time is 72 on 5 meters per second. Distance, if we want to work out the distance, well, obviously it's the area under a velocity time graph, or we can integrate and substitute our points in, all those wonderful things. So the area under the curve between 0 and 6 of 72 on 5, 1/15 of 6 minus t all cubed. Integrate, add 1 to the power, divide. Again, the negative sign in here will turn that into a positive. The 4 comes into the bottom of the 15 to make it a 1 on 60. Put 6 and 0 in. We end up with our 6 minus 6, which is obviously 0. 72 times 6 on 5. Simplify that on our CAS and we get a 64.8. So let's have a look at the example 12. Particle of mass 3 moves in a straight line and at time t its position relative to a fixed origin is x and speed of v. If the resultant force is 9 cos t and v equal to x equal to 0, find x in terms of t. So again, the sum of my forces is equal to ma. So we sort of got our 3a equals 9 cos, divide both sides by 3, and we get our a is equal to 3 cos t. So that's dv dt, integrate both sides. I've sort of taken a bit of liberty there. Antiderivative cos is positive, so I get 3 sine t plus c. Put our conditions in. Then we'll get an x is equal to 3 sine t plus 2. Integrate again. We get a rule for our position. So there's x in terms of t. So again, nothing brand new in there. A similar sort of thing, the resultant force is 3 plus 6x. Again, we have some initial conditions. Sum of the forces is equal to ma. So I know a is equal to 1 plus 2x. So then you've got the other forms. We've got our v dv dx and our d dx of a half v squared. I tend to go to v dv dx, to be honest, which I guess you end up at the same point, don't you? You end up with your half v squared on the left-hand side. Integrate the right-hand side with respect to x. X plus x squared plus c. Put your initial conditions in. And if I've done that right, we should get c equal to 2. So multiply 2 across everywhere. V squared equals 2x plus 2x squared plus 4. And then obviously if we put x equal to 2 in there, we get v squared is equal to 16. And our velocity is plus or minus 4, what's that, meters per second.